Okay, this is the second part of 3.1. We're going to talk about the vertex of a parabola whose equation is of the form f of x equals ax squared plus bx plus c. So notice the difference in the form, okay? It's no longer in vertex form. It's in the standard form of a polynomial. Very important. Okay, so in this, we have our vertex, and it's written like this. Our hk is now written, this is our h, and this is our k. All right? The x-coordinate is h, and the y-coordinate is k. And one can find the y-coordinate or k by subbing h into the function for the value x. Okay, so we can apply the same 5 steps, nothing's changed, for graphing the parabolas. Step for graphing the quadratic function with equations in vertex form. Still we do decide whether the parabola opens up or down, okay? Which is still based on A being positive or negative. We determine the vertex form, which takes just a little bit more math, because we have to use this formula to find h, and then once we find h, we plug h into our function. That's all that means, okay? And then we find our x-intercepts, once again, by setting y equal to 0. The real solutions are called the x-intercepts, okay? We want real, not imaginary. We find the y-intercept by setting x equal to 0. And what's really cool is that on this one, the constant terms of the equation are always going to be your y-intercepts. It's super awesome. You'll see that that's true. So it's always going to be 0 and then your constant. And then we're going to plot the intercepts, the vertex, and then sometimes additional plots just like before if you need them, okay? And then we just connect the dots in a bow-like fashion. Same thing, not a lot different, except for to find our vertex, now we have to use just a little bit of math, nothing hard. All right, we're just going to say it's going to be all negative. We're going to use b over 2a. We all know how to do that because we used something very similar when we did the quadratic formula, okay? Right, let's do it. First step. Does the parabola open up or down? Well, remember, a is always your coefficient in front of your x squared, right? So a equals what here? 1. B equals what? Right, -2. C equals 1. So that helps us with this whole thing. That's all we need to know for this. We really don't even need to know C, but might as well do that while we're at it. So our A equals 1, which is positive. So we know it's going to open up like a smile, right? Right on. Okay, now let's go on to 2. Now we're going to find our vertex point. We have to use our formulas, right? We're going to find h and k, but this time we have to find h. It's not given. So we already know that a equals 1 or b equals -2. So our formula for our h equals negative b over 2a. So b is already a negative. Remember how you do it with the quadratic formula. We're going to say -2 over 2. What's a? 1. All right. -2 becomes what? That's right, a positive. Over 2. What's, oh, shoot fire, that is a -1, and that is a -1. Man alive. How did I write that down? I don't even know. So sorry, guys. Off to a banging start here. So this is a negative. Good Lord, why didn't y'all tell me? Kidding. So it's going to be open downward. Yeah, baby. I gotta correct some more stuff. Hold the phone. Wait there a minute. I was just making sure y'all were paying attention. Negative. Okay, right on. So that's going to equal -1. Okay, all my mistakes are fixed now. Well, probably not all of them, but most of them. Okay. So that is a -1. So I'm going to write over here underneath this, h equals -1. Okay? So now that we found h, we know from before, we have to find k. So we're going to take f of -1. We're going to plug it in here. So that's going to be equal -1 squared, all right? Minus 2 times the -1 plus 1. And we're going to find out what that equals. So if you square a -1, that's a positive 1. So it's going to be -1 plus 2 plus 1. Those are right. I just looked at it, made sure. So this is going to equal 2. So we know all of that equals our k. So now our k equals 2. So we can write that as a point, right? -1, 2. So this is our hk. I bet half y'all are sitting there going, that's not positive. I do that when I watch videos of my teacher at home when I was in school. I'd be like, no, no, no. Sorry. All right, so now we have our vertex, 1, -2. So let's plot that. We're going to go to -1 and go up to -2. Glad I didn't plot it before that. Okay. Just like before. Now let's find our x-intercept. So we said y equal to 0, right? So we have 0 equals -x squared minus 2x plus. I'm sorry for this, but this is not factorable. So we have to do the quadratic. So a equals -1, b equals -2, c equals 1. -1, -2, 1. Yes, I got that right this time. Good job, Joe. And let's plug it in. X equals a -2 plus minus the square root of a -2 squared minus 4 times -1 times 1. All of this, some of you, no, that was my other class, sorry, I'm going to speak out of turn, times -1. So now we're going to say this equals, this is going to become a positive 2 plus minus square root 4 plus 4, right? Right on, -2. So it's going to be 2 plus minus square root of 8 over -2. What's the square root of 8 simplify down to? 2 square roots of 2, right on? All over -2. We can take this down even simpler. 1 plus minus square root of 2 over -1. Get rid of that -1 by writing this just as -1 plus minus square root of 2. We know that's two numbers, so let's write it as such, please. -1 minus square root of 2 and -1 plus square root of 2. If you do those estimations, that's going to give you -2.4 and 0.4. So we could plot these over here. -2.4 and 0.4. And then now let's do our, what new color there? That's good. Let's do our y-intercept. That means we're going to set x equal to 0. So we have y equals -0 squared minus 2 times 0 plus 1. So remember I said whenever you do your y-intercept, it's always just going to be your constant. So here you're going to see that. It's going to be 0 and this is going to be 0. So that's going to be y equals 1. So your x is always going to be 0 and your y is always going to be whatever constant it is. So that's kind of a shortcut for you because your x's are always going to be 0. So now we can do 0, 1 is going to be your intercept. And we can graph it now. The points are kind of off, but anyway, looks like it's turning to the left. Huh. Okay, and now we can do our axis of symmetry. So remember, that's always when h equals x. So what was our h? -1. So we know here is where we could fold it and it would look exactly the same. If I was a great grapher, it would. Now talk to me about domain. Well, it's a polynomial, yeah? So that would be all real numbers. Or you could look at your arrows, however you want to do it. And then range. Well, this goes on to negative infinity. And what's the highest it goes? Well, that's always your k. Awesome. Okay. Page. All right. Max and min values of quadratic functions. Consider the quadratic function f of x equals ax squared plus bx plus c. So if a is greater than 0, then f has the minimum that occurs at x equals h. Okay? This minimum value is your k. Now this is positive, right? We know that. So if it opens upward, that means you're going to have a min point, right? This is when your y is at its lowest. That's what this is saying. Your y is going to be your minimum point here when it's positive. Now, if a is negative, has a maximum point that occurs, and the max value is your k. And that's because when it's negative, like this, and at your h point, that's when your y is at its highest, okay? That's why that happens. Okay, so let's do this one. So first of all, we gotta look at this and say, is this gonna open up or down? Well, we have a negative, a equals -3. So we know negative people frown, so it's gonna go downward, right? So our point's gonna be up here. Does that tell you max or min? Absolutely maximum. Okay. Now, let's find, what's our b? Now let's find our h. So we know it's negative b over 2a, so it's going to be -6. 2 times a -3, which is going to give us -6 over -6. It's going to be 1. Okay, so we're going to put f of 1 in here. So negative times 1 squared plus 6 times 1 minus 13. -3 plus 6 minus 13. -16 plus 6, -10. Okay? So we know the maximum occurs, our x also equals our h, and that's at 1. So our x is 1. Our y also equals our k, that equals a -10. So we know this is at -10. Okay? Right on. Last one. Let me get some papers underneath it. so it doesn't tick, because I can't stand that ticking noise. Does it open upward or downward? Well, it opens up, right? A equals 2. What does B equal? -8, right on. So now, let's find H. So H equals what? -B over 2A. Okay, -B, so it's going to be a -8, yeah? Over 2 times 2. Negative times a negative gives us a positive, absolutely, over 4. So H is 2. So we know it opened up, so we're going to have a, sorry I skipped this part, a midpoint, so we're going to take this one. So we remember X equals H, they both equal 2, so this is going to be a 2. Okay. Now let's find K. So K equals Y or F of 2. So we have 2 times 2 squared minus 8 times 2 minus 3. Well, 2 squared is 4 times 2. That gives us an 8. -8 times 2, -16, minus 3. 6 and 3, 19, right? So 8 minus 19, -11. And we know that Y equals K, and they both equal -11. So that's where I get my -11 that goes right there. Do this on the last one, but let's talk about domain and range. So my domain here would equal what? Yes, all real numbers. What about my range? Think about it. It opens upward. So what's going to be my lowest point? Remember, it's always your K. Right. What's it going to go to? Positive infinity. All right, that ends this lesson. Have a great day.